Hi guys, I got a nifty little problem for you here. What we're going to be doing is we're going to be finding the area of this shaded region. Now we've got three circles. It tells us that the circumference of each circle passes through the center of the other two circles. And so in each situation we've got A, B, and C, and those are kind of the vertices of our little shape here. Now, what we're going to do is, I'm going to help you out a little bit. We're going to draw a little triangle here because I know how to deal with triangles. The other thing is that by drawing a triangle, it then also creates these little sectors that go up through here and up and around. Now, the purpose of the sector is because then I can find the area of this extra piece up here, which then there's three of those, which should be identical, which I can then add on. So essentially what we're going to do is we're going to take the area of triangle ABC, and then we're going to add on 3 of the area of the segment. Now, of course, remembering that the segment is going to be the area of the sector minus the area of the triangle. So you can tell we need to get the area of that triangle first. So being that the circles are of radius r, from the center of this circle to the edge right here, that's r. So the side of this triangle is r. So we've got r and r. So in order to get the area of this triangle, I have 2 sides. And because all the sides are the same, that means this is a 30, 60, 90 triangle, which means this is pi over 6. So from there, I can now use that to find the area of the triangle. So let's go ahead and do the area of the triangle first. So we go area of the triangle is equal to 1/2 times A times B times sine of, I just wrote pi over 6. What I meant was pi over 3. Should have been read anyway, so pi over 3, just like that for 60 degrees. Anyway, so then we've got 1/2 r squared times the sine of pi over 3. To get the sine of pi over 3, we draw our picture. There's pi over 3. We've got 1 to root 3, so sine is root 3 over 2. So there we go. We got the area of the triangle. Now what we need is the area of the overall sector there. So let's find the area of the sector. Now, of course, we know the area of the sector is 1/2 theta r squared. And so in order to do that, we'll go 1/2 times pi over 3 times r squared. And so that will give me the area of the sector. So essentially that will be pi over 6 r squared. So now what we will do is we'll get the area of a segment. And the area of the segment is the area of the sector minus the area of the triangle. So the area of the sector was this one, so pi over 6 r squared, and then we go minus the area of the triangle, which was 1/2, and we'll go ahead and put that together. I can't see any reason why not right now, so we'll just go pi over 3, square root of 3 over 4 r squared. So that right there is then the area of a segment. And so what we need to do is we need to take the area of the triangle, which was root 3 over 4 r squared, and we're going to add on the area of 3 segments. So 3 times pi over 6 r squared minus root 3 over 4 r squared. And we simplify each of that. We distribute the 3 to both of those. So I'm going to have root 3 over 4 r squared plus 3 pi over 6 r squared. That's a 6, not a 0. Minus 3 root 3 over 4 r squared. And so we've distributed the 3. Now we can start putting everything together to get our final answer. So it looks like I've got a root 3 over 4 r squared and minus 3 root 3. So the 3 over 6 will also reduce. So let's go ahead and reduce that. So I've got pi over 2 r squared, 1 root 3 over 4, and negative 3 root 3 over 4. So minus 2 root 3 over 4, which then reduces to 1/2 r squared. And then we take out the 1/2 r squared, which leaves us with 1/2 r squared. And then we're left with a pi there, and we're left with minus root 3. And ta-da! We're where we are supposed to be. 1/2 r squared is the same thing as r squared over 2. There you go. I told you that was a pretty nifty little problem. We are done.